Hello, good morning, guys. Our fourth topic, I think, of first chapter, class 11th, Venn diagram. In Venn diagram, the universal set is represented by a rectangular region and its subset are represented by circle or a closed geometrically figure inside the universal set. Also, an element of a set is represented by a point within the circle. That is, if we have u equals to 1 2 3 up to 10 and a equals to 1 2 3, then its Venn diagram is as shown in figure. You can see we can represent universal set, that is u, in rectangular region and its subset, that is a, in circular region, while the elements is represented by points. That is known as Venn diagram. It is a Venn diagram of universal set U within a subset A. Now we have operation on sets, union of sets. First of them is union of set. Let A and B be any two sets, then the union of A and B is the set of all those elements which belong to either A or B or both. It is denoted by A union B and read as A union B. The symbol union is used to denote the union. Therefore, A union B is equal to X such that X is belongs to A or X is belongs to B. For example, let A equals to 2 7 and B equals to 1 2 5. Then A union B will be 1 2 5 and 7. It means there is all elements which are belongs to A or B, but repeated elements cannot be the part of A union B. The Venn diagram of A union B is represented by this one, that is A union B. Now some laws of union of sets. For any three sets A, B and C, we have A union phi is always equals to A, universal union A is equals to universal, A union A is equals to A union B equals to B union A, and A union B union C is equals to A union B union C, which is known as rule of identity, universal, and so on. For example, let us take a set A equals to 1 2 3 4, B A B 2, C 2 3 4 B, then find A union B union C. We have to just find A union B. Firstly, A union B is equals to 1 2 3 4 A B. 2 is repeated elements, so we can write 2 only one time. Now we have to find A union B union C, so we have to make union with this with C, that is 2 3 4 B. Again here 1 2 3 1 2 3 is 2 3 4 is repeated elements and also B, so we can't write 2 3 4 B again and again. We have to just write one element at once. Now intersection of sets, let A and B be any two sets. The intersection of A and B is the set of all those elements which belongs to both A and B. It is denoted by A intersection B and read as A intersection B. The symbol is denote to intersection. For example, let A equals 2 3 4 9 and B equals to 1 7 6 4, then A intersection B equals to 4. It means the common element of both the set is known as intersection. You can see on Venn diagram of A intersection B, here the shaded region, this one is known as A intersection B. The region which belongs to A and also to B, that is known as A intersection B. Also the same laws for intersection of three sets A, B and C. Intersection phi equals to phi, union intersection A equals to A intersection A equals to A intersection B equals to B intersection A, and A intersection B intersection C equals to A intersection B intersection C, associative law. ध्यान रखिए यूनियन में जब हम यूनियन करेंगे तो हमेशा बड़ा सेट आता है, और इंटरसेक्शन में इंटरसेक्शन करने पर किसी भी सेट्स का जो छोटा सेट होगा वो आएगा। इसीलिए आप देख रहे हैं यूनिवर्सल में और ए में हमने जब इंटरसेक्शन करवाया तो हमारे पास ए आया, क्योंकि ए छोटा सेट है। जबकि आप यहाँ देख रहे हैं जब यूनिवर्सल हुआ था, यूनिवर्सल सेट के साथ जो यूनियन हुआ था, यूनिवर्सल का यूनियन हुआ था ए के साथ, तो बड़ा सेट क्योंकि यूनिवर्सल हुआ इसलिए यहाँ पे यूनिवर्सल सेट आया, और यहाँ पे पर्टिकुलर सेट ए आया है। तो जब जब हमारा इंटरसेक्शन होगा तो छोटा सेट आएगा, और जब यूनियन होगा तो फिर बड़ा सेट आएगा। डिस्ट्रीब्यूटिव लॉ बहुत इंपॉर्टेंट है, समझिएगा। इफ ए बी सी आर थ्री सेट्स देन ए इंटरसेक्शन बी यूनियन सी इज इक्वल टू ए इंटरसेक्शन बी union A intersection C. That is known as intersection distributes over union, and when union distribute over intersection we can write A union B intersection C is equals to A union B intersection A union C. Same as when we multiply three polynomial, then we can write same process. Now difference of sets. Let A and B be any two sets. The difference of sets A and B is in this order is the set of all those elements of A which do not belongs to B. When we find A minus B, it means the element which is belongs to A but not to B is known as A minus B. And for B minus A, the element which is belongs to B but not to A, that is called B minus A. These are the Venn diagram for A minus B and B minus A. You can see the shaded region is our result. A minus B means the element which are in A but not in B. You can see. For example, suppose we have A is any set with elements 1 2 3 9 and B 7 8 2 3. Then A minus B equals to 1 comma 9. Since 1 and 9 are belongs to A but not to B, the set of those elements is known as A minus B. For B minus A, the elements which are belongs to B, here 7 8 is belongs to B, but 7 8 is doesn't belong to A, so we can write in B minus A 7 comma 8, but 2 comma 3 also belongs to B and A, so we can't write 2 comma 3 in the set B minus A. Now our external topic, symmetric difference of two sets. Let A and B be any two sets. The symmetric difference of A and B is the set A minus B union B minus A. It is denoted by A symmetric difference B. It is important topic for competition level exam, but in NCERT book the topic is skipped. You can see A intersection B is equals to A minus B union B minus A. It means X is belongs to A or X is belongs to B, but X doesn't belongs to A intersection B. For Venn diagram of asymmetric difference B, you can see the shaded region is known as A minus B and the shaded region is known as B minus A. The union of these two sets is known as asymmetric difference B. Means this portion is not belongs to asymmetric difference B. For example, if A equals to 1 2 3 4, B 3 4 5 6, we have to find asymmetric difference B. Firstly we have to find A minus B, and A minus B is 1 comma 2, B minus A is 5 comma 6. You can see the union of these two sets is known as asymmetric difference B. Now another topic is disjoint sets. Two sets A and B are said to be disjoint sets if they have no common elements, that is A intersection B equals to 5. For Venn diagram you can see A and B are two sets with no common element, then these sets is known as disjoint sets. The sets A minus B, A intersection B and B minus A are mutually disjoint sets. That means the intersection of any of these two sets is an empty set. For any example, you can verify the intersection of A minus B and A intersection B, or A intersection B intersection with B minus A is always phi. Now again, next topic and important one is complement of set. Let U be the universal set and A be any subset of U. Then component of A with respect to U is the set of all those elements of U which are not in A. It is denoted by A complement or A bar or A dash and read as simple A complement. It means A complement is equals to X such that X is belongs to U but and X is not belongs to A. Or you can see for difference, for by the definition of difference, A complement is equals to U minus A. The elements which are belongs to U but not to A. Belongs to U but not to A. That is known as complement. For example, suppose U equals to 1, 2, 3, 4, 5, 7, 9, A equals to 7, 5, 9. Then complement of A is 1, 2, 3, 4. Means the all elements of U which are not in A. The set of these elements are known as complement of A. If A is subset of universal set U, then its complement A complement is also a subset of U. It means if A is subset of universal set, then its complement is also the subset of that universal set. Some properties of complement set: A complement के कॉम्प्लीमेंट को हम ए कहते हैं, इसको लॉ ऑफ डबल कॉम्प्लीमेंट कहते हैं. कॉम्प्लीमेंट का कॉम्प्लीमेंट हमेशा वो सेट बन जाता. ए यूनियन कॉम्प्लीमेंट इक्वस टू यूनिवर्सल सेट हो जाता है, जबकि ए कॉम्प्लीमेंट ए इंटरसेक्शन ए कॉम्प्लीमेंट इज इक्वस टू फाई. फाई का कॉम्प्लीमेंट यूनिवर्सल सेट होता है, यूनिवर्सल सेट का कॉम्प्लीमेंट फाई होता है. ए यूनियन बी का कॉम्प्लीमेंट यूनिवर्सल सेट में से ए यूनियन बी के एलिमेंट्स को सब्ट्रैक्ट करके मिल जाता है. अब सबसे इंपॉर्टेंट चीज इसके अंदर आती है कॉम्प्लीमेंट सेट के ऊपर डी मॉर्गन्स लॉ. स्टेटमेंट को ध्यान दीजिएगा. इफ ए एंड बी आर टू सेट्स देन द कॉम्प्लीमेंट ऑफ ए यूनियन बी, that is A union B, is equal to the intersection of complement of A and complement of B, or the complement of A intersection B is equals to union of complement of A and complement of B. समझें, the complement of A union B is equals to intersection of complement of A and complement of B. And same in second part, the complement of A intersection B is equals to union of complement of A and complement of B. हम इसको प्रूव करके आपको दिखा रहे हैं. Let suppose x1 be any arbitrary element of A union B complement, then we can say x1 is belongs to A union B complement. Suppose equation first, it means x1 is belongs to A union B complement, then x1 is not belongs to A union B. If x1 is not belongs to A union B, then x1 is neither belongs to A nor belongs to B. If x1 is not belongs to A, it means x1 belongs to A complement. If x1 is not belongs to B, then x1 belongs to B complement. If x1 belongs to A complement and B complement, it means x1 belongs to A complement intersection B complement. Suppose second equation. Now from equation first and second, in equation first we have x1 belongs to A union B complement, and in equation second x1 belongs to A complement intersection B complement. It means by the definition of subset, the elements which are belongs to A if also in B, then A is known as subset of B. So we can say A union B complement is subset of A complement intersection B complement. Equation third, again let x2 is belongs to, now in A complement intersection B complement, so same process, and we can find A complement intersection B complement is subset of A union B complement. Equation 6, and from equation 4 and 6, actually equation थर्ड एंड 6 होना चाहिए यहाँ पे. A यूनियन B कॉम्प्लीमेंट इज इक्वल टू A इंटरसेक्शन कॉम्प्लीमेंट B इंटरसेक्शन, और यही हमारे पास डी मॉर्गन्स लॉ था. इक्वेशन थर्ड में हमने ये प्रूव किया है और इक्वेशन 6 में ये प्रूव किया है. हमने आपको बताया था कब इक्वल करना हो, अगर A सबसेट है B का और B सबसेट है A का, तो इन दोनों से हमको मिलता है कि ए इक्वल है बी के। And now Venn diagram, that is A union B complement is equals to A complement intersection B complement. A intersection B complement is equals to A complement union B complement. You can see the shaded region is our answer. A union B complement नहीं होगा, A union B ये रहा, ये नहीं है, इसको सेट नहीं किया हमने, इसके अलावा सब कुछ सेट किया है। और यहाँ पे देखें A इंटरसेक्शन B कॉम्प्लीमेंट, A इंटरसेक्शन B नहीं होगा, A इंटरसेक्शन B यहाँ पे है बीच में पोर्शन, ये कॉमन पोर्शन, ये नहीं है और सब हैं, दैट इज़ नोन एज कॉम्प्लीमेंट। और ये डिमॉर्गन्स लॉ है, आपको प्रूफ करने के लिए एग्जाम में आएगा। और ये असाइनमेंट आप इसको नोट कर लीजिएगा। नाइन क्वेश्चंस हैं और इन्हें केयरफुली कीजिएगा। थैंक यू।